Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday technical session. Here's our topic for today. Today is the start of a 4-part series on the IEC 61131 programming languages, and we're starting with ladder logic. Now at Horner, we like to provide our customers with lots of options, and when it comes to programming languages, we offer several. We still support the original register-based advanced ladder that was there in Cscape way back in 1998. More recently, we added support for variable-based advanced ladder, which we cover extensively on the channel. Now, for years, we've also supported the IEC 61131 programming languages, but here in the States, we've been a little bit slow to adopt those. Certainly, our customers have. And probably it's partially our fault because we probably don't spend enough time in promoting them. Today we're going to change that as we're going to start this 4-part series on introducing IEC so you can decide if it's right for you and your applications. Okay, let's break down the topic. Now this is a week in which we pre-recorded the video. However, we're still streaming it live on Tuesday. So if you're watching it live, you can give us your comments as well as your questions in the chat section. Now if you're watching it on replay, you can do the same, but just give it to us in the comment section instead. Today we are going to answer the question, what is IEC 61131? We're also going to discuss why that at Horner we give you multiple logic options in Cscape. We're going to help you answer the question why you might choose IEC 61131 for your application. And then we're going to have a demonstration where we're going to introduce to you IEC ladder through variable handling, ladder tools, and debugging. Let's get started. First of all, what is IEC 61131? Well, the bottom line is it's a standard for the implementation of programmable controllers and their languages. So it wasn't established by any single company, but really by a committee. And that is important for some customers because they really feel like they want to follow a standard and not necessarily a manufacturer's approach. Now, part 3 of the IEC 61131 standard covers programming languages. So keep that in mind. Now, here at Horner, we tend to just talk about IEC when we're talking about this programming style, and that typically includes all of the languages. Let's talk about why we do offer multiple logic programming options in Cscape. First of all, a lot of automation users have strong preferences when it comes to logic programming. They have a certain programming language they prefer, and therefore that's what they want to stick to. At Horner, we originally offered just one option for programming languages way back when Cscape was created in 1998, and that was register-based advanced ladder, which was really the most typical language for the day. But just a few years later, we added support for the first time for the IEC 61131 programming languages. That was back around 2003 or so. Recently, the last few years, we've added support for variable-based advanced ladder, which again, we do cover extensively here on the channel. And then last year, we added enhanced IEC support, which we'll talk about here in a minute. Again, at Horner, we've opted to add these options without removing any of the original ones. So why might you use IEC 61131 for your logic? Well, again, for some users, following a standard is very important. You use equipment from multiple manufacturers, and you feel that by using IEC 61131 programming languages, you have the best opportunity to have similar programs from manufacturer to manufacturer. Now, keep in mind, the IEC 61131 is a standard, but it doesn't mean that the exact logic you develop for one manufacturer can be directly downloaded into another unit from another manufacturer. It's not quite that standard, if you will. The other big reason, or at least it's the biggest reason as far as I'm concerned, is that you want to support multiple languages even in the same project. with the IEC programming languages, there are 5 languages that are standard and 4 that are still very commonly used. And each of these languages is a little different and has their own strengths and weaknesses. Now, while ladder logic is very versatile, that's one of the 5 options, other languages that are offered, like structured text, offer their own advantages for certain programming tasks. So again, from my standpoint, the big advantage to supporting IEC or using IEC is the ability to support multiple languages even in the same project. Now let's get back to that enhanced IEC that we added here at Horner last year. What is enhanced IEC? Well, it's not part of the standard or anything like that. It's just an enhancement that we made to our IEC languages just last year for capacity, performance, and more. So starting out with the capacity, the enhanced IEC option in Cscape supports 50,000 variables instead of the previous limit of 10,000 for standard IEC. It executes faster at runtime. We've added support for online programming. That means you can make programming changes without stopping your controller and taking it out of run mode. We've also added simulation, so you can simulate your application even before you do the download. There is one extra requirement for simulation, and that is you have to opt in to provide Horner with feedback from Cscape. It's not a major request, but it's one that we make to enable simulation. Now, it is true that for enhanced IEC, you do need a small license fee to be paid per controller. So you license the controller in the field. It's a very modest fee, but it really gives you all those capabilities I've just outlined. But keep in mind that enhanced IEC is not supported in the micro OCS, although standard IEC is. So everything I talk about today is going to be fully applicable to all Horner products. Now let's talk about the ladder logic editor in Cscape. Now, one of the first things you'll notice today during the demonstration is that the look of the ladder logic editor in the IEC option in Cscape is not exactly the same as what we use for advanced ladder. That's because the IEC version follows more closely the PLC open standard. However, don't worry, after some practice and a little bit of orientation, you can use it very efficiently. In order to enable support for IEC programs in Cscape, there's a little work you do have to do in the Tools Applications setting area of Cscape. So by default, Cscape does not have a checkbox checked for IEC support. So you need to go into the Tools Applications area and check that checkbox. Once you've done that, if you still have multiple options checked, every time you start a new application or a file new, you're going to be presented with your choices of register-based advanced ladder, variable-based advanced ladder, or the IEC 61131 option. That's enough preliminary information. Let's go ahead and get started by showing you how to use the IEC 61131 ladder logic editor in Cscape. Now, as we get started with our demonstration, there's a couple things I want to show you right off the bat. First thing I want to show you is that, let's go ahead and just create a new file. You'll see that when we create a new file, we have multiple options for the logic languages. Now, these options only show up if we've actually enabled them all in the applications, the Tools Applications settings area. So let's show where those are enabled. So I'm going to go to Tools, Application Settings, and support for IEC editor programs has to be checked for you to have that option when you create a new program. Now, if you are interested in taking advantage of enhanced IEC, then you'll want to check that checkbox as well. But remember, it does require a small license fee or a small fee to be paid for the license for enhanced IEC before you can download that program into a Horner controller, and that is a per controller fee. Okay, so that's the first thing I wanted to show you. The second thing I wanted to show you, especially since so many of you are not that familiar with the IEC languages, and that is that in the help file, let's go to the contents here. There is just a wealth of information available on Cscape in general and in IEC in particular. So if we see here under creating and editing control logic from the Contents tab, if I click on that, you can see that I have all kinds of information on the different options and a lot of information on IEC specifically. So there's a user's guide. It talks about enhanced IEC versus standard IEC, the different languages that are available and all the different implications there, as well as function blocks, etc. So just lots of great information that's available in that help file, especially for those of you who are new to the IEC 61131 programming. Now we did create a new program in an earlier step here, so I'm going to go ahead and start showing you the ladder editing. Now there's nothing I'm going to do in this demonstration that requires enhanced IEC. And if you noticed when I showed you my application settings, I had enhanced IEC checked by default. So if you've done that and you have a program that was created with enhanced IEC in mind, but you don't really want to use it with enhanced IEC, then you can go to Tools, Editor Options, and then under Compiler Options, this is where for this particular program, you can uncheck the enhanced IEC. Because again, there's nothing I'm doing here that really requires enhanced. Now, if you do choose to use enhanced IEC, it reminds you that the device needs to be licensed, and your display validate license is what you can use to actually go ahead and apply the license to your OCS. But I'm going to uncheck it here and hit OK. To get started, we've just got a blank applications area here. Let's go under main loop modules and right click and say new logic block. So as you can see with IEC, we've got several different options in terms of our languages for each individual block that we configure. So I just want a ladder block. I'm going to go ahead and select one here. And then you're given an opportunity to name it. So I'm just going to give mine a simple name like motor start. Maybe that's the primary function of this particular ladder block. Now you can notice here that the editing area does not look the same as advanced ladder. That's okay. It's just different. It follows more closely the PLC open standard. So there's a little bit of orientation you'll need to have here. Now before we get started in actually drawing our ladder logic, let's make sure that our program variables window is available to us. And currently it's not selected. I'll click it here, and then I like to have it floating as opposed to being docked. That's just my particular preferences. So there we go. So let's just build a simple start-stop ladder circuit. We start with up here in the left-hand corner, and we start by pressing this Insert Contact Before button. And you can see it also has a keyboard shortcut of Shift F4. So when I press this, it adds a contact in the first location, and it also adds a coil at the same time. So let's make this our start push button. I'm going to go ahead and create this, I guess, on the fly. So I'll start by saying start push button, press the green check mark here. So far you can see it's basically identical to what we do with variable-based advanced ladder. Go ahead and make it a global variable, and then let's go ahead and map this to I1, because this is, let's say, an actual hardwired push button. There we go. Now in series, we're going to want our stop push button. So with the first contact highlighted, we're going to press the next button here, which is Insert Contact After. Again, we can double click. I'm creating variables on the fly. Stop push button. Again, a global variable Boolean is fine, and we're going to map this one to I2. Again, another hardwired push button. We don't have to map internal variables, but these are hardwired contacts. You'll notice my stop push button is normally open. Generally, stop circuits or stop contacts are normally closed. We can check this or select this swap item style with that contact highlighted, and it changes to normally closed. Let's go ahead and add another contact to the right. We'll make this our e-stop. Again, I'm creating on the fly. You could pre-create your variables just fine. And we'll make this, let's make this I4. Okay, so we skipped I3, we're making this I4. All right, for no particular reason, that's just because how it's wired, let's say. And then now we need a parallel contact to seal in the motor starter, but let's define what that motor starter variable is first. So I'm just going to call this motor starter. Again, I'm creating on the fly, and let's say this is a physically wired motor starter that we're going to wire to the first output or Q1. Now we need this parallel contact. So what we do is we highlight the area where we want to add the parallel contact, and then we press this button right here, which was insert contact parallel. And we can just select a motor starter in this case, but because we've already created it, it's here on the list for us to grab. So we've done our very simple start-stop ladder circuit. Now let's go ahead and pull up our screen. I've got an EXLW here, and we're going to do something extremely advanced. We're just going to put a big old pilot light on the front here to indicate the status of the motor starter. All right, so this is no different than what we would do in variable-based advanced ladder. Okay, I've selected motor starter. For my legend, I'm just going to say motor run with a larger font than what is available by default. We'll make on green and off red. That's fine. And there we go with our high-tech screen. I'll go ahead and change the background to something different. I like different background colors. I'm going to go with this nice green blue or blue green. All right, and there we go. I think we're just about ready to download this to our controller because I did start this from scratch. Connected locally here, I do have an EXLW, which is what I'm programming, that's currently in stop mode, but I do need to make sure that my Ethernet address, because I'm programming over Ethernet, I do need to make sure my Ethernet address isn't going to change, so I'm going to hard code that like that. Now I should be ready to download it. So I'm going to go ahead and execute the download. It's giving me a warning because my hardware configuration is being downloaded while I am programming over Ethernet. So if I didn't get that right, it could cause problems. First download always takes longer, of course. And we're complete. So let's go ahead and put the controller in run mode. And let's take a look at the application. So I've got my handy dandy I/O simulator hooked up to the system here. Remember, we have to have an e-stop circuit active. Let's go ahead and do a debug. It'd be easier to do that than to look at this view. So let's go back to Cscape. Let's go into debug mode. And let's see where things stand. Okay, so it looks like our e-stop is true and our stop push button is false. So on my handy dandy I/O simulator, I'm going to flip switch 1, which should be my push button. And there we go. I let go of my push button and the seal seals it in. So as we look at this live, if I execute the stop push button, that's switch number 2, then I'm not running anymore. Restart with switch 1, stop with switch 2. Okay, simple stuff. Let's get out of debug here and let's do a little bit of scaling. So let's say that we've got an analog input value and we want to scale that from 4 to 20 milliamps to, let's say, 0 to 100% for the level of a tank or something like that. So let's go ahead, and this time instead of programming everything on the fly, let's define our variables first. So under global variables, I'm going to add a new one. I'm going to press the insert key here. Okay, and I'm going to call this one tank level analog. Let's stretch this out a bit so we can read it better. Let's change this to an integer. And let's say this particular one is wired to analog input number 1. So we're going to memory map it to %AI1. And then let's say we're going to create another variable. This time I'll right click and hit add variable. And this one let's call tank level percentage. We'll make this one an integer. All right, and it's just an internal variable. It doesn't need to be memory mapped to anything. So let's go ahead and add the ladder logic that's required to do this scaling. Now, I'm going to go ahead and put my cursor here and click it. And I'm just going to go ahead and type in insert function block before. With IEC, you don't actually have to have an always on contact before your function block. It's not a requirement. So you can choose to do that for consistency's sake because that's how you're used to doing it with Horner, or you can just not do it. It's your choice. So it's added a function block, but it didn't specifically pick a particular function block, or at least not necessarily, it didn't pick the one I wanted. So I'm going to double click on this function block here and go through and pick the one that I want. So I want a scaling block. So I'm going to go to the arithmetic section. Nope, it's not in there. Go to the maths section. Nope, not in there. Let's go to advanced and see if we can find, yep, there it is. So the scaling blocks are available under advanced. All right, so do we want a real or do we want an integer? Let's just go ahead and do integer scaling. So I'm going to double click on that. And now I can start filling it in. Now, one of the differences with IEC is you basically fill in your values for your variables, your constants, in the areas next to the function block, not inside the function block itself by double clicking it. When you double click inside of a function block, you basically select the function block that you want. Now I've hovered over the function block and we can see all the requirements for the inputs and the outputs. It looks like everything needs to be an integer. That makes sense. So our input, I'm double clicking there. Let's select our predefined variable. There it is, our tank level analog variable. That's there. Minimum, that's coming in at 0. Let me double click here. Just type in a constant of 0. The maximum is a constant of 32,000. My outputs, if I'm scaling from 0 to 100, then I'm just going 0 there. I'm double clicking on every one of these areas and to 100 there. And my output is going to be that tank level percent. All right. Now, every time I add a function block or create a new rung, I automatically have this coil that's created, but I don't have to define every one of those. So it added the coil automatically, but if I don't need a specific coil there at the end of this function block, I don't have to configure it. I can just leave it alone. Let's do an error check and see if everything looks good so far. Everything looks good, no errors or warnings. Now let's go ahead and go to our user interface And let's go ahead and add in a data field so we can monitor the values that we're getting from, or we can monitor our scaled values. So I'm going to pick a data field. And again, this is not any different than it would be in variable-based advanced ladder. All right, I'm going to select a, let's go ahead and select a signed decimal here. And 3 digits. It's in percent. The reason I did signed here is because you could have a value below 4 milliamps that shows up as negative. So if it's 3.9 milliamps or something, your percentage is going to be a little bit negative. So I want that just to go ahead and show up okay. I could go ahead and do some other programming things to get rid of that, but I'll just leave it alone for now. Variable wise, let's pick tank level percent. And it's not writable, it's read only. And under legend, let's select tank level. Oops, let's spell it right though. Put in a decent size legend, and we went ahead and added our percent sign. So that looks good. Oh, our tank level size is way too small. Let's make it big. See if it fits. It does. Okay. And let's go ahead and make the background of this guy white instead of gray, just for grins. All right, so there we go. I've added that. I'll go ahead and change the size a little bit. Close it. Let's go ahead and check for errors. Everything looks good. When I'm checking for errors, I'm hitting this error check icon there, just in case you didn't catch that. I'm going to go ahead and do a download. Let's do that. Let the project download. Now that download is complete, let's take a look at what things look like on the bench. And I'll switch over to my handy dandy I/O simulator and start adjusting, oops, not the encoder, the milliamp signal. And you can see as that goes up, we're scaling from 0 to 100%. So that was using an integer scale block in IEC. So for the last part of our IEC ladder demonstration for today, let me add a timer to the system. So let's go ahead and time how long the motor is running, and then let's automatically stop the motor after a certain amount of time. So to do that, we need a timer. So I'm going to need a new rung. I'm going to go ahead and click here on the first column, and one of my options is, before, when I created this rung up here, I just did a contact before, insert contact before. I just press that button to create a new rung, and I could do that again. Another thing I can do, another option I have, is I have this insert new rung button there as well. So I'm just going to use that one this time, just to do something different. Okay, and what we want to time is we want to time how long the motor starter is on, to time how long the motor's running. So let's pick that from our list of existing variables. Motor starter, there we go. And then let's insert a timer in here. Now, I can do the insert function block thing like I did before, or over here from my toolbox area under timers, I can pick the timer I want. Now I want an on timer, let's say with 100 millisecond resolution. So I'm going to click and hold, and then I'm going to drag that over to here. And you can see it's inserted it in. Now you can see the question marks here. It's wanting me to name this guy, which I'm going to go ahead and do. So I'm going to call this my motor run timer. And it's creating a variable of the type on delay timer 100 milliseconds as a global variable. That all looks good. I'll leave that there. So it's looking for a preset value, which can be a variable or a constant. For this demo, let's just make it a constant. So I'll double click here and type in, say, 5 seconds or 50 counts. And then let's go ahead and assign a variable here to the current accumulated count so we can monitor that. Let's just call that motor time. And you can see, there we go, motor time as an integer. So that looks good. I'll hit OK there. And then when this expires after 5 seconds, let's make this our auto stop. Okay, I don't know when we would do this, but if we wanted our motor to automatically stop when this timer expires, we could do that. So let's call this auto stop. Another internal variable. And then let's add between the stop push button and the e-stop, let's go ahead and insert a contact before, and let's make this a normally closed contact by hitting this swap button here. And let's double click and select our auto stop. So that's the logic that we need. Now let's go ahead and go to our screen and add a data field. We'll just copy this one and modify it to monitor how long our motor is running. So we have tank level %. This time we want a 16-bit value, and instead we want motor time. We don't want percentage, we want seconds. We don't need a signed decimal, just a decimal will be fine. And we want to display this with an implied decimal point right there. And we want our legend to say, let's say motor run time. All right, I think that's good. Yeah, that looks fine. Let's go ahead, and I think we're ready to download. Let's just error check first, just in case I made a mistake. Here's our error check button. That all looks good. Let's go ahead and download. Let's switch over to our bench view, and let's go ahead and start our motor. And after 5 seconds, we should see it turn off, which we do. That worked as we wanted. Hopefully, this little demonstration for a few minutes will give you a feel for some of the differences if you're using the IEC ladder editor versus the advanced ladder editor, whether that's register-based or variable-based. From the standpoint of the variable handling, it's very, very similar to the advanced ladder variable-based. So not a lot of differences there. So for those of you who have become familiar with that programming style, this shouldn't be difficult at all. Let's go ahead and wrap up our topic. We talked about the fact that Cscape offers multiple options for logic programming, including IEC 61131. We talked about the reasons why you might choose IEC 61131 for your applications. Maybe the adherence to a standard is important. Maybe it's the availability of multiple languages. We also talked about the availability of enhanced IEC 61131 in most OCS models, but not the micro OCS. Enhanced IEC 61131 offers more capacity, more speed, and more tools, but it does require a modest per unit license fee. Now, as a reminder, we're here every Tuesday at 2 o'clock, whether we're fully live or whether we are streaming live a pre-recorded video, but we're always standing by to answer your questions in the chat section. Next week, it's part 2 of this series, where we focus in on structured text. I do want to remind you, if you haven't done so already, don't hesitate to subscribe to our channel. It doesn't cost anything, and if you choose notifications, you'll be notified every time we go live or every time we post a new video. All right. Hope to see you again next week. And everyone, let's get out there and do some good.